Alright, so now we come to the very last subtopic for the chapter 1, Algebra, which is binomial expansion. Alright, so maybe you ask, last time we learned the binomial expansion in AS level, but why we learn here again for binomial expansion in A2? Alright, so for A2 syllabus, the binomial expansion, generally we are only focused on the power of n, which is rational number, and also not a positive integer. All right, so you need to know how to expand it. The method will be a bit different from what we learned before in AS level. All right, so let's have a look for all the binomial here. Binomial expansion here. Okay, so again, binomial expansion for A2 syllabus, we are going to focus on when you're having 1 plus x power n. Okay, so we want to apply the formula when n is a negative integer or rational number. So negative integer means that, I think very obvious that if let's say you're having negative 1, okay, negative 2 and so on, power negative 1, power negative 2. So you cannot use the AS method to expand the binomial expansion. So what you need to do is you have to apply another new formula, right? So the same thing happens for the power with rational number. So rational number means that in short, it's a fraction like this, like 1 over 2, then negative 3 over 2, and so on. All these are the power. Alright, so when you're having the power of rational number or negative integer, generally you need to apply a new formula to do the binomial expansion. Okay, so it is a bit different from what we learned in AS before. Okay, so the formula is actually given in the formula booklet, but if, let's say for me, I would prefer you to memorize it at the same time. Alright, okay, so again, let's have a look for the pattern here for the formula. Okay, so generally, when you want to apply the formula for binomial expansion for this A2 level 1, there are a few things that you need to know. First, you have to make sure that 1 as a first term before you use the binomial expansion formula for A2. Okay, so that means this first term here must be a 1. It cannot be 2, cannot be 3, cannot be any other thing. It must be start with only 1. Alright, and then usually the term with x, I will put it as a second term. Alright, so this is some simple rules that you need to know. Okay, and then they are talking about for this binomial expansion, it is valid when x smaller, modulus x smaller than 1. So for this one, the valid value of x, I will explain to you later what does it mean. Okay, so maybe let us have a look for the formula first. Okay, so you're having 1 plus x power n. Okay, so the first term, this is the first term. Alright, so the first term is always the 1. Okay, it is for sure 1. The first term is always for 1. It's always a 1. So if let's say you want to find the proof, maybe you have to find online. Alright, and then for the second term here, the second term here is you always take n multiply with x. Okay, then how about the third term? So the third term will be n, and then n minus 1 divided by 2 factorial x power 2. Then the fourth term is this one, n minus 1, n minus 2 divided by 3 factorial x power 3. And this binomial expansion can actually goes until x power infinity. Alright, so therefore we put dot here. Okay, it can go until x power infinity or maybe x power 100 and so on. Alright, okay, so for us, we only list out until x power 3. Okay, if I want to continue to expand for another one for x power 4, so will you be able to write out the formula for x power 4 or not? There are actually patterns here. Alright, so I hope that you can see from the pattern and you can try to do some induction and see, you can know that the x power 4 maybe is n minus 1, n minus 2, and then you extend further, n minus 3 divided by 4 factorial, and then you multiply it with x power 4. Okay, so if they want you to expand until x power 5, so again, you can just extend more terms, right? If you want, if the question want you to do so. So you have x minus n minus 3, n minus 4 divided by 5 factorial and also x power 5. Okay, all right. So if they still want you to continue, of course you still can continue, but in exam, most of the time, at most they will ask you to expand the x power 3 or only x power 4. But I'll prefer you all to remember the pattern of the formula. Okay, so for this binomial expansion, generally it seems like very easy because you just apply the formula and you can get an answer. What you need to do is you just need to avoid all careless mistakes. Okay, all right, so this is the formula for the binomial expansion in A2. Okay, so again, to apply this formula, there are a few things that you need to know. One more time, the first term of your binomial expansion here, this this term must be always the 1. Okay, all right, and after that, there's another rule. So another rule, we call it as this one. This is another condition that must be fulfilled. All right, so what is this meaning? This meaning is, okay, usually in the question, they will tell you that valid value of x. Okay, so that means to make this binomial expansion formula become a true or a correct formula, you must follow the condition that the value of x that you substitute into this equation must be smaller than 1. Okay, but it is not always modulus x smaller than 1. It actually depends on the equation that you have. Okay, so as an example, for this example, right? Okay, wait. Okay, so for this example, this particular example, okay, we are having 1 plus x power n. So how can you write out the valid value of x? So the valid value of x, very simple. It is actually always modulus x. You take the modulus second term smaller than the value in the first term. Okay, always is like that. So as an example, if let's say I'm having one binomial expansion formula is 1 plus x over 2 power n. So what is the valid value of x for this binomial expansion? So it will be modulus x over 2 smaller than 1. Okay, so modulus 2 is still a 2, right? So you can bring it over, become modulus x smaller than 2. So this is how we write out the valid value of x. Okay, so that means if later when they want you to substitute some value into the x, you cannot substitute the value of x modulus x which is not less than 2. Okay, so maybe we can expand it further. Some book they will write it like this, modulus x smaller than 1, which means -1, x is between -1 until 1. So this formula you learned it from modulus function before, right? When we say modulus x smaller than 1, it means what? It means that the value is between -1 until 1. So that means you can substitute the value of x into this equation only between -1 until 1. If you substitute 2 into the x in the formula, that means the answer that you get will be a wrong one. Alright, so that is the meaning of valid value of x. So the same thing happens here. If modulus x smaller than 2, that means the value of x that you can substitute into your binomial expansion is between -2 until 2. If you substitute any value other than this one later, then the answer that you get is actually a wrong one. Alright, so if let's say we got time, maybe we can discuss this valid value of x later. But for now, we will only focus on how to do the expansion and how to write out the valid value of x. Alright, so how to apply this one, we will learn it maybe later in the last video for this whole chapter or what. Okay? Alright, so this is what you need to know before you can apply the formula. Okay, alright. So again, please remember all the rules. Alright. Okay, so maybe you can discuss some example here. Okay, so I maybe will try part B for you, which is harder, and then you try part A yourself. Okay, alright. So for part B, you are having this one, right? Okay, so before you do any binomial expansion for A2, you need to read the question very carefully. Okay, so here they said they want you to expand it in ascending power. So usually in ascending power, no need to worry one, because when you expand everything, it is always in ascending power. Alright, they say up to and including the terms in x power 3. So that means you should expand until x power 3. And also they want you to write out the values of x, which expansion is valid. So that means they want you to write out the valid value of x for this expansion. Okay, so you have to read carefully first, okay, before you want to do any expansion here. Okay, so I will start with this one. Okay, so 2 over square root 1 minus 3x. I will want to bring the 1 minus 3x become a bracket with a power. So square root should be half, but because it is at the denominator, right? So when you bring it out, it will become negative half. All right, so this is the first step. First step, you must show your expansion in a bracket with a power first. Okay, then after that, 2 is a constant. Generally, you don't need to do anything. Okay, all right. So if you look at this bracket, so first of all, you please check and see the first term. Is it 1? Yes. Okay, so if the first term is a 1, that means you can straight away apply the formula that you learned just now. Okay, so what is the expansion here? First term is always a 1. Okay, and then second term is nx. Okay, so now what is your n? You should know that the negative half is your n. And then what is your x? This whole thing at the back is your x in the formula. All right, so you should remember, you should know this. So the negative 3x is actually the x in the formula. Okay, so when they said n, have negative half. Okay, and then x is negative 3x. Okay, then next term you have n, which is negative half, n minus 1, negative 3 over 2, divided by 2 factorial, and then negative 3x, the whole thing squared. So x squared, that means the whole thing of x, negative 3x, you square it. Okay, then the next term, they want you to expand under x power 3, right? Okay, so next term is negative half, negative 3 over 2. Oh, not enough space, so I think I better write it down. Okay, so, all right, so I'm having plus again. Okay, so n minus 1, n minus 2, divided by 3 factorial, and then the x power 3. All right, so if you want, you can just put the dot here. All right, okay, so now I will stop at here because they only want me to expand it under x power 3. Okay, so what you need to do next is just press calculator and try to get the final answer. So I keep the 2 outside first. I simplify everything inside. Okay, so if I try to simplify everything inside, I think I will have this now. Okay, please correct me if let's say I did any kind of mistake here, and you can double check. All right, whether to see whether I did kind of mistake or not. Okay, so if I just expand all the thing inside the binomial expansion, this is what I get. All right, and then after that, I multiply the 2. Okay, multiply the 2 into the whole expansion. Then this is what I get. Okay, so this is my final answer for the binomial expansion. Okay, so after you've done the expansion already, then what you need to do is you need to write out the valid value of x. So again, to write out the valid value of x, you always look at the formula. Okay, so this is the whole thing, the second term, right? So you should write modulus negative 3x, then always put smaller than the number in front, so which is a 1. Okay, so when you're having modulus negative 3x, it will become modulus 3x, the negative disappear, right? And after that, you have modulus x smaller than 1 over 3. So when you write it out in your step, you write it at the end. So modulus x smaller than 1 over 3. Okay, so this is the expansion with the valid value of x. Okay, so for all this, no need to show in exam. Okay, they won't give you any marks for this one. They will only look at this answer to give you 1 mark. Okay, all right. So this is how we do apply the binomial expansion formula and also write out the valid value of x. So we learn all this basic first. Then only we discuss the application for the valid value of x later. Okay, so again, please try type A yourself. You should get this answer. All right, and then the valid value of x is x smaller than 1. Okay, have a try and see whether you successfully get this or not. And then if let's say you can get it, then maybe you can try it out for a few extra example in the tutorial question or the exercise behind every single chapter. Okay, or maybe I should say that the tutorial question or the exercise I give you, okay, in Blackboard. All right, so just make sure that you try to apply it and familiar with the steps and also the formula. Okay, all right, so this is what we have for example 16, part A and also part B. Okay, so again, like what I said just now, the binomial expansion formula can only apply when you are having the first term start with 1. Okay, so this example at 16, you can see that both also start with 1. But in exam, they are not going to be so kind, right? Sometimes they'll give you some expansion that the first term is other value, like maybe 2, 3, 4, or even some fractions. So if let's say you have this kind of problem, then how can you do the binomial expansion, right? Okay, so you just need to do some adjustment before you want to do the binomial expansion. If let's say the first term is not the 1. Okay, so like if let's say I'm having a plus bx, it is not 1 plus x, it becomes a plus bx. So what you need to do is like you have to take out the a, follow with the power, and then inside the bracket you need to divide it by the 8. Okay, then after that you straight away apply the binomial expansion formula by referring to this bracket only, because this bracket now the first term become 1. Okay, then you continue with the formula that we learned before. Okay, all this don't need to memorize. You just need to remember that, okay, after you do the adjustment, after you pull out the value for a with power n, then the bracket here, you just apply the formula that you learned just now. All the concepts are the same. So this is only one step extra. That means you need to pick out the a, value of a from the bracket to make sure that the first term is a 1. Okay, then all the formula here, it looks like very complicated, but no worry, you don't need to memorize. You just remember the original one that you learned just now. Okay, so I will show you one example here also. Okay, so for example 17, I will try part A. Part B, you try yourself, but part B is not related to what we discussed on top. So you just try first. Although it's a bit complicated, all right, but you try first. And then maybe again, you can practice this, okay, by trying out some other tutorial questions. Okay, so I will start with part A. So for this part A, if I want to do the binomial expansion, it will become 3 minus x power negative 2. I cannot apply the binomial expansion formula straight away here because the first term is not start with 1. Okay, so what I need to do now is I need to do some adjustment before I can apply the binomial expansion formula. All right, so what I need to do is like I take out the 3 with the power, and then my bracket now inside will become 1 because you pull out the 3, right? So it become 1, then minus x over 3, and then the power remain. Right? Okay, then after that, 3 power negative 2 is 1 over 9 actually. So you don't touch anything with 1 over 9. It is a constant, so you just keep it here. And then you just expand the bracket 1 minus x over 3 minus 2. Okay, because the first term now it already start with 1. So you can start to apply the formula. Okay, so again, before you do any expansion, look at the question again. They want you to have ascending power of x up to and including the terms in x squared. So just now it's x power 3. Now they only want to have it until x squared. Okay, so what you have here is, again, first term is always a 1. Second term is nx, so your n is negative 2. X is negative x over 3. Okay, then n minus 1 divided by 2 factorial, and then the whole thing power 2. Okay, so if you do this binomial expansion correctly by pressing calculator and didn't do any careless mistake, you should have 1 plus 2 over 3x, and then plus 1 over 3x squared. Okay, and then only now you multiply the 1 over 9 in, then you have 1 over 9 plus 2 over 27x plus 1 over 27x squared. Okay, and this is how to write the valid value for your x. So again, you can look at the original equation if you want. This is the original equation. If you want to base on this one also can, up to you. Right, so I will look at the original one. So this one means modulus negative x smaller than 3. Smaller than the number in front, right? So modulus with negative x, it will become modulus x, so smaller than 3. Therefore, I put it here. So modulus x is smaller than 3. This is my value of x. Okay, so usually what I would tell students, this part is actually very easy to score also, just that you have to make sure you didn't do any careless mistake. You have to be very careful because a lot of students will do mistake on maybe this one, they forget to cancel off the negative when you square, or when you press calculator, you press it wrongly and so on. Alright, so it is easy to score, but it is also extremely easy to make careless mistake. So please make sure you double check your step when you are dealing with all this. Okay, right. Then now I will discuss with you how to do part B, and then you try out on your own. Part B is not related to this one we explained before, because you see both are start with 1. Okay, but no matter how, I will just guide you how to do it, and then you try and see whether you can get the answer or not. Okay, so for this one, square root for the whole bracket, right? You can actually write it out, become 1 plus x power half on top divided by 1 minus 2x power half at the bottom. Okay, so to do the expansion, you need to actually bring both brackets on top. So if let's say this one, you bring it out, you will become 1 minus 2x, then you have negative half. Okay, all right, so now they want you to expand everything in x squared, right? So after you do it like this, both bracket first term are also 1. Okay, so maybe for this one, you do the binomial expansion, okay, and then you will get the answer in red. Okay, so you have something plus something x plus something x squared. You have to expand that x squared. And then maybe for this bracket, you also apply the binomial expansion formula, and then you will get your answer in green color. So this bracket also has something 1 plus something x plus something x squared. So when you have these two, right, and they are multiplying each other, so that means you have to multiply. Like first term multiply with first term multiply with second term, and so on. Expand everything to get the answer. Okay, so to get the answer, if you continue it correctly, right, you should able to this answer. Wait, you should get this one. Okay, can I show you the red color part first? You should get 1 plus 1 over 2x minus 1 over 8x squared. Then the second term is 1 plus x plus 3 over 2x squared. Okay, so this one I put dot, you have to complete it yourself. Okay, then after you expand and multiply everything together, the correct final answer should be 1 plus 3 over 2x plus 15 over 8x squared. Okay, all right, so now, some students will say, when you do the expansion here, right, okay, like this one, 1 over 8x squared and also 3 over 2x squared. You know that when you multiply them together, you'll become x power 4. Do you still need to write x power 4 here or not? You can skip it if you want. Okay, you just consider everything until x power 2. Okay, so this is what we highlight as the final answer. Okay, then now we discuss how can we get the value of x when you're having two binomial expansion. This one got two binomial expansion, right? Red color and also the green color. Okay, so again, for the binomial expansion, we need to consider both. So for this one is modulus x smaller than 1. For this one, I will have modulus x smaller than half. Okay, so you can, by using the common sense, modulus x smaller than 1 means that it is between -1 and 1, all right? Okay, then the green color one is between -half until half. Okay, so to make this whole equation correctly, what you need to do is like you only consider, okay, the smaller value of x, which is valid one. Okay, so you choose this one. That's the correct final answer. I cannot choose this. Can you imagine or not if, let's say, you select x equals to, let's say, between half, okay, you put 0.75. So if let's say x equals to 0.75, in this binomial expansion, it is correct, but when you apply it in this binomial expansion, it is wrong. So you have to make sure that you choose the value of x, which is correct for both one. Okay, so usually the smaller one will be correct for both. Alright, so the green color one will be the correct one. For the correct value of x, for this one is modulus x smaller than half. Okay, so please try and see whether you can get the answer or not for this one. So this one is a bit complicated because you need to expand both and then you combine it. Okay, and then for the first one is what we learned just now. You need to take out the value to make the bracket, the first term of the bracket become 1 first before you can continue to the formula. Okay, so this is what we have for the binomial expansion part. Okay, but all these are basic only. That means you just need to apply some very basic knowledge. So please practice first. Okay, so please practice first. Make sure that you know everything well. Like you know how to write out the correct value of x, how to combine two separate binomial expansion become one correctly, and so on. So after you practice a few already and you find that, okay, you already have the idea how to do this, then only you continue to the next video. So the next video we are going to discuss the exam style question. So for exam style question, usually most of the time, they will actually combine it with partial fraction that you learned before. So it will become a bit complicated. Although it is a bit complicated, but to me, it is not hard, but it is very tedious. Okay, all right, so we will discuss that kind of question in the next video. All right, so please make sure you practice and familiar with this part first.